Section 7.2, Multiplication and Division of Rational Expressions. So we've talked about polynomials, we've talked about rational polynomials. Now we're going to do some algebraic manipulation on these polynomials. I'm just going to go ahead and snip all this, and we'll talk about it. Alright, so recall that to multiply fractions, we multiply the numerators and multiply the denominators. The same is true for multiplying rational expressions. So real quick, this line here can pretty much, we see it here. 2/3 times 5/7. Well, we essentially just multiply the numerator, so 2 times 5 is 10, and then 3 times 7 is 21. And then we're saying that it's essentially the same thing with rational expressions. So if we notice here, we multiply numerators, right? 2 times 5 is 10, x times z is xz, 3 times 7 is 21, and then y times 1 would be y, right? And then so this leads to a more rigorous definition here. It goes on to read, sometimes it is possible to simplify a ratio of common factors to 1 before multiplying. To do so, we must first factor numerators and denominators of each fraction. So similar to how we would factor these numbers to simplify the fraction, we're going to do the exact same thing with the rational polynomials. We'll snip this three-step process here along with example 1. Now step 1, step 2, step 3, again, as I've said before, I might not follow these steps 1, 2, 3, or I might not say them 1, 2, 3, right? But that's just because it's not necessarily rigorously memorizing these algorithms, these steps. It's mainly just to understand the procedure, right? Again, if you were to make a sandwich or something, you don't go, okay, this is what I do, this is step 1, this is step 2. You just do it. Okay, that's essentially the same thing we're doing here. Okay, so I'll leave the steps in place, obviously, and we'll just see if I follow along, right? So first thing I'm going to do is I'm going to rewrite it. Looks like I don't need to rewrite it. Okay, so there's no need to rewrite this as I don't need to factor anything. So I'm just going to go ahead and multiply the numerators, okay, and then I'm going to multiply the denominators, just straight from here. So 5 times 6 is 30. A squared times a is a cubed. There we go with the 3's again. And then b. And that's all over. 2 times 10 is 20. And then b. Okay. And then from here, we see that the b's cancel. This 3 and this 2 can be reduced to a 3 halves. So all I have is 3 halves, and then what remains with my variables will have an a cubed. And that's it. Okay, so let's see if I followed these steps. Number 1, factor numerator and denominators. Okay, so I didn't factor. I didn't feel like there's much need to factor. I'm sure I'll show you the way the book does it, and I'm pretty sure they just multiply the a's out and stuff. So step 2, simplify the ratios of common factors to 1. Okay, multiply the remaining factors. All right, yeah. Again, we don't have to follow that. No big deal. And yeah, sure enough, it does. It does 5 times a times b, right? We're not going to write that, are we? We're just going to glide along like it did in the example. Example 2. Okay, so we're going to do the same procedure here, except we are going to factor now. Okay, so we're going to rewrite it in a factored form. So rewriting in a factored form, I'm going to have I'm going to factor out a 3 in the numerator on the left, so 3, and what remains is a c minus d, and that's over 6c, and times, and then that c squared minus d squared, well, I know that is a difference of squares, so it's going to be c plus d followed by c minus d, all under 2. Okay, and once we get to this point, we can now look into canceling, right? So we can essentially cancel this, and again, canceling is just essentially turning into 1, right? And that needs to be remembered for later on when we do what we did on Monday, when we canceled and we got a -1. Okay, so again, canceling does not mean that it's just going away. Okay, it just essentially turns into a 1, but we don't write it because we're not writing 1s everywhere, are we? Okay. Anyways, looks like we can reduce this to a 1/3, so we'll put that 1 there, and this, I'm sorry, 1/2 and a 2 here. Okay, and now we can proceed. So everything's canceled. So what do I have in my numerator? Well, if I multiply my numerators, well, it's just 1 and then a canceled c minus c, which is essentially again a 1 times a 2. So I've got a 2 in my numerator. In my denominator, I've got a 2 and a c plus d. Okay, so we've got a 2c and then a c plus d. That parentheses looks an awful lot like a big C, so we're going to try that again. Okay, we're not done though, because we see that these that the 2, they can cancel, right? And then again, this turns into a 1. And so we will have a 1 over c times c plus d. Avoiding mistakes. If all the factors in the numerator reduce to a ratio of 1, a factor of 1. Okay, yeah, that's a good one. We're going to keep that there, or we're going to snip that and put it on the current page. Just like that. Okay. And basically what this avoiding mistakes is saying is essentially what we did right here. Okay. It says if all the factors in the numerator reduce to a ratio of 1, okay, a factor of 1 is left in the numerator. So what happens is we canceled the 2's here. All right, there's still a 1 there. It's an implied 1, but in this particular case we have to write the 1 because otherwise, this fraction would look silly, with nothing over, right? So yeah, we have to put that 1 there. I've got really good news. Today's going to be a pretty short day. I think a lot of it, at least. All right, so I taught this in this Alex textbook this past spring, and I do remember going through lectures pretty quickly. I mean, I guess it does help that I don't have to actually write these problems down or write the definitions down. But yeah. Anyways, so example 3, we got a lot of factoring to do here. Okay, so we're going to factor the numerator. I always start. I mean, I couldn't imagine why anybody would start differently, but I always do this first, this second, this third, that fourth. Okay, again, I couldn't imagine anybody doing it a different way, but if you do, no big deal. Okay, so let's rewrite it. So it looks like I can factor a 5 out of the numerator here. So if I factor out a 5, I've got a 7 minus x in my numerator. My denominator, it looks like I can also factor out a 5, and what remains would be an x plus 1. And then over here, I can factor this x squared plus 5x plus 4. It looks like it would factor into my factors are 4 would be x would be 4 and 1, so x plus 4, x plus 1, and then x squared minus 4. No, that's a difference of squares, so it's going to be x plus 7 and x minus 7. Okay, so we can proceed. So it looks like these 5s, they essentially cancel. Looks like I can cancel. Okay, now this is from the other day. Well, first let's get this x plus 1 out of the way. Okay, this is from the other day. What I'm going to do here is I'm going to cancel this with this. Okay, because if we look, this is a positive 7 and a negative x. This is a positive x and a positive 7. Okay, it's the exact negative. So I can cancel it. All right, but I have got to make sure that I put that in times -1 out here. Okay, I always put times -1 to the outside to just remind myself. I believe the textbook, what it does is it puts the -1 above, or -1 replaces this, and that's fine as well. I'm gonna go ahead and do it my way. It's just the way I've been doing it all along, and I feel like it's a lot easier instead of putting the 1 there. Okay, so again, I'm gonna go cancel, cancel. I know they're the exact negatives, so I'm gonna say times a -1. Okay, all right. So now I can write this problem out. Okay, so that -1 is going to tell me right away, that this fraction is going to be a negative. So I'll put a negative out front. If I can make it a little bit straighter. Yeah, there we go. All right, my numerator, what do I have my numerator? Well, it's an x plus 4. So I don't have to put a parentheses there. So x plus 4. And then what do I have in my denominator? Just an x minus 7. No. Hang on a second. The plus. Oh, I canceled the wrong thing. That's what it was. All right. So if I confused you, let's start over. Let's go back about 40 seconds. Sorry. This cancels with this. Sorry about that. So this is a positive 7 negative x. I guess I said it wrong. I don't know. Positive 7 negative x. This would be a positive x negative 7. So it actually cancels with this one. I'm so sorry. So times -1. I mean, same procedure there, but I was writing the wrong one there. So x plus 4 again in my numerator. Right, it's a negative. Account for that negative. X plus 4 in my numerator. My denominator is x plus 7. Okay. All right. So again, just a quick recap. Right. So everything that we're used to, everything we've done, we should be used to. Okay. But when we cancel here, bam, bam. As soon as you do that, make sure you put the -1 right here. Okay. And then whenever you go to actually write the fraction with all the leftovers, take that negative and put it right here. Just put it in front of the fraction. Okay. And then from there, obviously, you would write whatever is left over. Okay, so hopefully that little hiccup didn't confuse you too much. If it did, you can email me. Or, talk to me after class. Yeah, see, here's what I'm talking about. So the textbook, and again, there's nothing abundantly wrong with it. It puts the -1 right here. But then at the same time, I feel like it kind of makes it, you have to put the negative up here in the front, which you would think, or in front of the terms in the numerator, which you would be like, okay, so I want to distribute, right, things like that. And I mean, these two obviously are equal to this, but this is what we got on our when we actually worked the problem out, and it just, in my opinion, just looks a lot cleaner. Okay, put the negative out front. All right, so now division, everybody's favorite. I guess I have to snip all that, do I? I wonder if I can fit the problem in there. It doesn't look like it'd be too long. Maybe we can fit it on the same page. All right, so excuse me, division of rational expressions. Recall that to divide two fractions, multiply the first fraction by the reciprocal of the second. Okay, so you might have forgotten about this. If we have this fraction, 21 divided by 10, 21 over 10, divided by 49 over 15. All we do is take this fraction, flip it to 15 over 49, which you see here, and change its division sign to a multiplication sign, and then do the multiplying across. Okay? If you recall, that's all we have to do. And also, just a quick little pro tip, and this is a problem that even some of my calculus students that I've had before also had problems with. And this isn't part of the lecture, per se, but it is part of the lecture, right? So I will have a problem like this, in a later course, right? College algebra, pre-calculus, calculus, and a student sees this and they're like, ugh, I'm done. Because we don't like fractions, first of all, right? And we sure as heck don't like fractions over a fraction. But again, if you just recall that this is just as easy as saying 21 over 10 divided by 49 over 15, and then it immediately comes back to you, oh, okay, so we multiply by the reciprocal. Okay, so this is something that I'm sure many of you will forget in time, but it isn't that difficult. And of course we have our more rigorous definition with letters that basically is the same thing as this example up here. Okay, so let's try to tackle this, and it does look like there's going to be some factoring first. Let's go ahead and rewrite this factored. So it looks like I can pull out a 5 in my numerator there, so it looks like I can say 5t minus 3 over 2. And I'm going to go ahead. No, I'm not going to go ahead. Never mind. All right, and then my numerator is a difference of squares, so it looks like a t plus 3, t minus 3. Over 10. Okay. Now I will do the multiply by the reciprocal here. So just rewrite the one on the left, easy peasy. Now I'm going to have a multiplication symbol here. I can make it a little bit bigger. Yeah, that'll do. And then I've got t plus 3, t minus 3 over 10, or under 10 rather. Okay. All right, now we can proceed with our fun canceling. So this t minus 3 is going to cancel with this t minus 3. It looks like this 2 will turn to a 1, and this will turn to a 5. And that's it. So I'm just going to multiply my numerators here. So I've got a 5 times 5 is 25. Nothing else there. And then my numerator, let's make that better. Put it in green as a final. How about that? That's maybe what I should be doing. Or at least circling it. I don't know. 25 over t plus 3. And that's division of rational expressions. So I'm pretty sure we're going to get a little bit harder. Let's see. Yeah, we got 7 examples today. Busy. All right, so, oh my goodness, this looks absolutely not fun. Let's begin. Okay, so it looks like the numerator over here, my factors of 30 would be 5 and 6, and it looks like they're both being negative, so it's going to be a p minus 5, p minus 6 over, looks like I can factor out a 10, so I'm going to p squared minus 25. Okay. All right, so p squared minus 25, I know is the difference of squares, so I'm going to go ahead and put that difference of squares in place there, right? So I'm going to go ahead and rewrite that as p plus 5 and p minus 5. Okay. and then divided by, looks like I can pull out a 5p. And so I've got a 6 minus p. 6 minus p, but we can write that as p minus 6. All right, so here's, okay, so I'm going to proceed. I'm factoring out a 5p. Well, that doesn't really help there, does it? I'm factoring out a 5p out of the numerator here. So if I factor out a 5p, what remains would be 6 minus p. Okay. Trying to think. I guess that'd be fine. Yeah. All right, just trying to think ahead here with the cancellation. All right, so if I factor out a 5p, got 6 minus p. I don't know why that's bothering me so much. And then 2p plus 4, I'm going to factor out a 2. What remains would be a p plus 2. Okay. Now I can rewrite this. So I'm going to rewrite this as, I might have to go to another page. That's unfortunate. So I'm going to make sure I split this up nice and neat. P minus 5, P minus 6, divided by, and then we've got a 10 P plus 5. And of course we can start the cancellation process early, but for the sake of being very, very extra thorough, we're not until we rewrite this. And I believe that's what the avoiding mistakes said earlier. And then okay, so let's snip this and put this on the next page. There we go. All right, now we can start the canceling process. So it looks like right away, the p minus 5s, we knew that was going to cancel out, right? We have a p minus 6 and a 6 minus p right here and right here. Okay, so again, I'm going to cancel them, but then immediately I'm going to put, times -1 right here, just to keep track. And then it looks like, well, that's it. Okay, so now I can proceed for the finish. So this -1 here tells me I'm going to have a negative fraction. Okay, now real quick, the reason why I like to put the -1 there as opposed to the way that the textbook does it, and there's nothing wrong with the way the textbook does it. I don't know if we're going to have an example today or later, but just going to give you an idea of why I put it there. Here's why. Okay, so let's assume that this and this, all right, this is a p minus 5 in the numerator. Let's assume that it was a negative p plus 5 in the denominator. Okay, and if I canceled it, I would put a -1 out here as well. Okay, and therefore I would have two cancels that produced a -1. Well, this tells me that I would have a -1 times -1, and then, of course, negative times a negative is a positive, so I wouldn't change the sign of the fraction at all. All right, so that's why I like to put that -1 out there, just in case there's, more than one -1s to account for. But anyways, since we don't, we can simply put the negative out front for a negative fraction. Oh yeah, looks like this turns to a 1 and this turns to a 5. Okay. All right, so looks like we have p plus 2 in my numerator. P plus 2. And my denominator looks like it is just going to be the 5 times 5 is 25, so 25p. And p plus 5. And that looks good. So 20p, yes. Okay. How funny is that? Okay, so I know I've seen something like this before when I reviewed this section, but I gave you a little pro tip earlier, and we do indeed see it here. Okay, so this is the fraction over a fraction. It's not as difficult. Well, it might actually be easier actually than what I gave earlier. But again, something like this, you're immediately gonna be like, oh no, fraction over fraction. I hate fraction over fraction. But just stay calm and rewrite it. So if we rewrote this, this could be rewritten as 3x over 4y divided by 5x over 6y. Okay, and we know then it could be rewritten as 3x over 4y times 6y over 5x. Okay, and then from here it looks like we can cancel the y's. Looks like cancel the x's. That's easy. This turns into a 3. This turns to a 2. And it just becomes simply, what, 9/10? Okay, that easy. Again, don't be freaked out by fraction over fraction. As with all fractions, it's always easier than it looks. And I've noticed that, but even then I still hate fractions. Ain't that a thing? Yeah, 9/10. All right, and we are here at the last example, 27 minutes into our lecture. Okay, I think I might have got ahead of myself, so let's go back and see if I skipped anything in the paragraph. It reads, sometimes multiplication and division of rational expressions appear in the same problem. In such a case, apply the order. Okay, that's actually good. And it might be a nice little segue into something else I can talk about. Okay, so we are familiar, obviously, with PEMDAS, right? Parentheses, exponents, multiplication, division, addition, subtraction. Okay, so obviously, yes, PEMDAS, right? But it is more like this. PEMDAS, where, and this is probably going to be super confusing. I don't know. We'll see. Okay, so what you do is you do perform the order of operations. Okay, but just because M is in front of the D, okay, so in PEMDAS, right, doesn't mean we're going to multiply. So in this case, if we were to follow PEMDAS religiously, we would do the multiplication of that first. Okay, and what this is saying up here, I guess I got pretty use a laser there. What that's saying up there is that we don't have to necessarily follow that order of operation here. Instead, we just read it from left to right. Okay, so obviously for PEMDAS you do parentheses exponents, but then when you have multiplication and division, just do it from left to right. That's what I do with the arrows there. And then when you have addition and subtraction, just do it from left to right. And left to right means, looking at the problem and just working again left to right. Okay, so let's do that. Hopefully that's not too confusing. We can rewrite this as, and we're not going to write in white, so we're going to have a 4 over, and it looks like c squared minus 9, we know that is c plus 3, c minus 3, and that I don't like that. Alright, we're going to rewrite this. So c plus 3, c minus 3, 4. Okay. And I'm just going to go ahead and flip here, so I'm going to say multiplied. Oh, let's eraser. Multiply by c minus 3 over 6. All right, and we're going to do this part first, and we'll deal with this part in a moment. So the 3c over 8. We'll deal with that in a moment. Okay. Okay, so it looks like here we can cancel the c minus 3. This turns into a 3. This turns into a 2. And I think that, yeah, I mean, makes sense. Okay. So now we can rewrite this. We can say it's 2 over 3 c plus 3. Okay. And then now we can look at this part. Okay, I did write that right? So c minus 3's cancel, c plus 3's left. 2/3, everything's good. Okay. So we're going to multiply it by 3c over 8. Okay. And from here, it looks like we can just multiply again straight numerators and the denominators. So we got 2 times 3 is 6. We got 6c over 8, 16, 24. So 24 c plus 3. And then the 6 and the 24, that reduces to a 1/4. So I can write 4 c plus 3 all under c. And that's it. Yeah. All right. And that does conclude today's lecture.